This is lesson 1-4, adding and subtracting algebraic expressions. So we have some very special names for algebraic expressions. If we have a one-termed algebraic expression, it's called a monomial. A two-termed algebraic expression is called a binomial. A three-termed algebraic expression is called a trinomial. And anything bigger than that, we simplify by just calling it a polynomial. Let's discuss like terms. So as you can see below, I have a couple of examples of what like terms and not like terms should look like, but let's have a couple of rules to go along with them. The first thing is that like terms have to have the same variables. As you can see in my examples on the bottom, all four of them, we have 3x and 4x. They have the same variable. Now, the reason I have the s in parentheses up top there is because it's an option to have multiple variables. In fact, for terms, you don't even have to have a variable at all. 3x and 4x are like terms. And the other rule, of course, is to have the same exponent assigned to the same variable. Now, as you can see in the like examples, like for the second one, negative 2y squared and 5y squared, they have the same variable, y, and they have the same exponent assigned to that variable, the 2. If you look over to the red, where we have the not like terms, especially the one that's furthest to the right, we have negative 2x squared y and 4xy squared. They have the same variable and same exponent. However, the squared part is with the x in the left term and the y in the right term. That's what makes them unlike terms. So the rules for adding and subtracting monomials are as follows. The biggest and most important rule is that we can only add and subtract like terms. Once you have determined that you have like terms, you add the coefficients or subtract if that's what it dictates, and then leave the variables and their powers alone. Do not touch variables or their powers when you are adding and subtracting. If you see yourself with no coefficient in front of a variable, you may assume that there is a 1 there. And be sure to follow all the rules for addition and subtraction of signed numbers. Now, I haven't directly given you notes about addition and subtraction of signed numbers. However, you very easily can take a look back in notes that you've taken in 6th, 7th, and 8th grade, if you still have them. Take a look at how you add and subtract signed numbers. You also, at all times when you're doing arithmetic, basic arithmetic with addition, subtraction, multiplication, division, should be using a calculator to check your work. There are two methods to adding and subtracting polynomials. The first is the vertical method. The procedure is pretty much the same as monomials, meaning that we only add or subtract like terms. We want to line up the polynomials so that like terms are underneath each other. Here are some examples that we have. The left example is one of addition. And we're going to use this sign right here for both the x's and the y. So 3x plus 5x gives me 8x, and 4y plus negative 2y gives me a positive 2y, and that would be my final answer for that one. This one we're going to subtract all the way through. Sometimes it may help to just put a line here just to remind yourself that you're subtracting the whole time. 8x squared minus 6x squared is 2x squared. 4x minus a negative 4x gives me a positive 8x. A negative 8 minus a positive 5 gives me a negative 13. Now, what I prefer is the horizontal method. This procedure involves the distributive property that we did in the last lesson. You want to write the problem horizontally and put each polynomial in parentheses. Then you write the number 1 in front of each set of parentheses, followed by distributing and combining like terms if necessary, and it will most likely be necessary. Here's some examples. So, the first one, I want to put ones in front of both and distribute the 1 all the way through. That gives me 3x plus 4y plus 5x minus 2y. I combine like terms, the 2x terms and the 2y terms. That'll give me 8x plus 2y. And as you can see, I'm using the exact same examples from the left side just to show you that it doesn't matter which method you decide to use. So there's my answer for the first one. Second one, again, putting ones in front, distributing all the way through, I end up with 8x squared plus 4x minus 8. Now be careful, I'm distributing a negative 1 here with the second set of parentheses. So minus 6x squared plus 4x minus 5. Combining like terms gives me 2x squared plus 8x minus 13. Again, same exact answer from the vertical method. You have the right to choose whichever method you so desire. Quite frankly, you should probably try both to see which one you like better and not just go on my words and actions. Here's some examples for you to do. These are all monomials. Pause the video at this point to give yourself a chance to try them on your own. Here are your answers. 6s plus 4s is 10s. 8x squared minus 3x squared is 5x squared. 5a minus 4b is exactly written as such because they are unlike terms. There is nothing I can do. 8z squared minus a negative 4z squared gives me a positive 12z squared. 4x squared y to the 5th plus a negative 8x squared y to the 5th gives me a negative 4x squared y to the 5th. 9x to the 4th minus 3x to the 3rd. There's nothing I can do because they are unlike terms. The next one here is a little tricky because they look to be unlike terms, but you have to think about your properties from the last lesson. When you subtract 0, you get the exact same thing. So the answer is negative 3x. Remember that 0 is the additive and subtractive identity element. So you can just go straight to negative 3x. And finally, for the last example, negative 12xy plus 24xy gives me 12xy. Here's some more examples for you to try. Simplify these algebraic expressions. Pause the video at this point to give yourself a chance to try them on your own. So regardless of the vertical method or the horizontal method, you should have been able to come up with the correct answers. For the first one, it's 9x squared minus 12x plus 15. For the second one, we have 3x squared plus 4x minus 5. Next, we have 10x squared minus 8x plus 3. And finally, 12x squared minus 9x plus 14. Let's try a word problem example, a short word problem example. The length of a rectangle is 8x squared plus 5 inches. The width is 3x squared minus 6 inches. Represent the perimeter. Remember that it's a rectangle, and each rectangle has 2 lengths and 2 widths. Maybe you want to draw a picture and label it out before you start the problem. Pause the video at this point to give yourself a chance to try it on your own. So as I said, you should be drawing it out. Draw yourself a rectangle. The length is 8x squared plus 5. It also means the opposite length is 8x squared plus 5. The width is 3x squared minus 6. So is the opposite width. So what we should be doing here is now adding all of these up. So 8x squared plus 5 plus 3x squared minus 6 plus 8x squared plus 5 plus 3x squared minus 6. I then, I'm doing the horizontal method, we'll put ones in front of all of these, distribute the ones all the way throughout, and then combine like terms. My final answer when I do that is 22x squared minus 2 inches. And it is important to have the unit involved since we were talking about inches in the original problem. If you're having any issues in any portion of this lesson, please make sure you email me or consult me in class.